if it's absolute of everything, do you guys remember what to do? Absolute of everything means everything at the bottom, so under the x-axis becomes, yeah, you're just reflecting anything that's at the bottom to the top. Okay, so I'm just going to write it as a quick note because you might need it as we move on. So reflect. Do you girls remember what to do? Erase. I'm going to summarize. Erase the left. Reflect the right. Yeah? So what do I mean by that? Erase the left side of the graph, which is so anything that side, and then reflect the right. So we're going to reflect this part onto this part. So that's my answer. Do you remember that?
Yes.
Okay. This time, you take the top, erase the bottom, reflect the top to the bottom, reflect top to the bottom. Okay? So what does that mean? It means we're just going to take the top part of the graph above the x-axis. You erase the bottom, so ignore anything below the x-axis, and then reflect this top to the bottom. So that's how you do absolute of y, absolute of inside. Okay? So when there's two things, here's what you want to do. One, you want to do what you did for this. Okay? So let's do that. So what did we do when the absolute was just inside the x? Yeah? So we erased it, and then we reflected that. So this was my answer for this. Now, once you've done that, then you want to do absolute of y. So what did I do in absolute of y? We took the top, erased the bottom. So anything at the bottom, we erased. Okay? And remember, this is gone as well now because we erased it. And then reflect the top to the bottom. So reflect this to the bottom. Oh, it's meant to, look symmetrical. Okay, so. Okay, the first step is, as usual, do the inside first. Absolute the inside. Okay, and we know how that looks like. What do I do again? Get rid of that. So, sorry, it should look symmetrical. Yeah, so we've done that. Now, do absolute of everything. So if I absolute everything, going back to the first example, what did I do? You reflect anything that's in the bottom to the top. So this part is gone. I'm working with this now. So what do I do with this part? That's my answer. And what does that mean? You're taking, it's the first example. Yeah? That's my first step. Second step, do absolute of y. What did I do when it said absolute of y? You take the top, erase the bottom. There's nothing at the bottom, so that's good. And then reflect the top to the bottom. So it's going to look like this.
Wait, then why would you show us the answer if you told us to do it?
Oh no, this is eventually the answer you should be getting.
But that makes sense.
Okay, so here's how you do it. Firstly, do it here. Girls, when x equals to 0, what is the y value based on the graph? So when x equals to 0, y equals to 0. Is that all right so far?
Yeah.
Yep. Now, girls, isn't writing 0 the same thing as writing 0 squared? Yeah. So, and we've established that the x value of 0 equals to y equals to 0 on the graph. Okay? That means, what that means is, so on the new graph, when x equals to 0, y equals to 0. Because the question is, sketch x squared, and at x equals to 0, or 0 squared, it's 0. So this is my first point. Okay? Secondly, we're going to look at all the square numbers, and you'll see why soon. Okay, secondly, when x equals to 4 on the graph, when x equals to 4, what's the y value? 0, yeah. Similarly, girls, 4 is the same thing as writing 2 squared, is it not? And we've established when x equals to 4, which is 2 squared, it's equal to 0. Why do I want to write it like that? Because it means on the new graph, when x equals to 2, y equals to 0. Yeah, because you're only taking that part because that's what they want you to sketch, x squared. So that's a technique. So when x equals to 2, let's just say it's here, y equals to 0. So that's my next point. Does that make sense? It's a bit confusing it's a bit of a very confusing technique to get. We're trying to use the original y values and seeing what it equals to on the new x value. So square root of 4 is 2, and it's the same value. Let me keep going, okay? How about, firstly, on the graph, on the original graph, right? When x equals to 2, what does y equal to on the original graph? 1, yeah? That means, girls, isn't 2 the same thing as writing, sorry, I'll write it like this. Isn't 2 the same thing as writing root 2 squared? Yeah, and that's equal to 1 because root 2 squared is the same thing as 2, which is equal to 1. Now this is 1.4 roughly. So that means on the new graph, at 1.4, let's say it's here, at 1.4, what does it equal to? 1. So that's my new part as well. Oh, sorry, all the way to 1, all the way to 1. Yeah? You all right, Sharon? Any question? Keep going? Okay, let's do a couple more. Girls, what does y equal to on the original graph? When, oh, sorry, not 3, sorry. Let's have a look at 9. Let's have a look at a really big number. So all the way here, right? Let's say that's 9. So what's the y value at x equals to 9 in the original graph? On the graph, it's actually like really close to. Well, what's that value close to? Let's just say it's minus 3, but it's not obviously exactly minus 3, but let's say it's minus 3, yeah? Because the reason is, now, the 9 is the same thing as writing what? 3 squared, that's right, and that's still equal to minus 3. So that means on the new graph, when x equals to 3, y equals to minus 3. So, when x equals to 3, y equals to that very line, like close to the asymptote. Can you see what it might look like? It's actually like the same graph, but it's just been shifted. I'm not done yet. Because, no, almost, but because, but no, this is the important part. But also note, girls, in a bracket, girls, what's minus 2 squared? 4. And what does y value equal to when x equals to 4 in the original graph? 0. So can you see that, or even on the other side, so at minus 2 is equals to 0. Let me make it straight. Let me skip. Girls, it's actually the same graph on the other side as well. Because girls, x squared, it's any value you put in x, it's always going to come out as a positive number. So whether you put minus 2 squared or plus 2 squared, it's going to be the same. So whatever y values you get for positive x values, it's the same as negative x values, which is the reason why you reflect it on the other side, and that's your answer.